Okay, so I'm promising you new school here. Let me see if we can show this to you so it makes some sense. So I'm doing the exact same problem that I just did for you guys, but I'm going to show it to you in a way that maybe you can save yourself a little bit of math trouble. So it's the same idea, but we're going to do it as a rice table. And what we mean by rice is the R stands for reaction, I stands for initial, or how much you have of everything in moles, okay? Moles, not grams, moles. So you have to do one conversion before you start. Change, or how everything changes when you're doing this. And then E is for end, what you wind up with, okay? So you have 31 grams of graham crackers. How many moles is that? Well, when we were talking about this when we all started, it wasn't all that bad. If you want to go from grams to moles, you divide by the molecular mass. Well, you have that here. You divide by 7.75, that means you've got 4 moles of graham cracker. Okay, well, let's divide all this stuff up here for a second. Try to make this as neat as I can. Make your table work. So this is where I really want you guys to think about what your balanced equation means. So in order to make this reaction work through one turn, you need 2 pieces of graham cracker and 1 marshmallow and 1 piece of chocolate in order to make 1 s'more. If you make 2 turns through, you're going to need 4 graham crackers, 2 marshmallows, and 2 pieces of chocolate to make 2 s'mores. Ah, there we go. 4 moles. It's the same idea with moles or just individual particles. So you've doubled everything. So initially, I've got 4 moles of graham cracker. That means if I'm going to make this balanced, and that's what we're going to assume here, that we've got this balanced perfectly so we can make enough. I know I need 2 moles of marshmallows and 2 moles of chocolate. Now, we haven't made anything yet. It's like you've got this stuff heaped up on a plate. You're ready to make your s'mores, but you haven't done it yet. So before you start, you have nothing. That's what it means to have a reaction. You've got all of your reactants, but you haven't made anything yet. You've got nothing for products. Okay, so when this changes, how much of your graham crackers are going to disappear? Well, all of it. You intend on using them all up. You want to eat them. You're going to use up all of your marshmallows. You're going to use up all of your chocolate. Oh, well, you're going to make all those s'mores up. Well, it's 2 to 1 to 1 to 1. So it's going to do the same thing that your marshmallows and chocolate do. 2. So when you're done, you're not going to have any graham cracker left. And we're assuming we're 100% efficient. We're not making things complicated yet. We're not going to have any marshmallows left. We're not going to have any chocolate. And we're going to have 2 s'mores. We're going to have 2 moles of s'mores. Okay, well, let's make this simple. How much s'mores are we going to have in grams? Well, wait a minute. This is moles. All you have to do is do 2 times the mass. So the s'mores as a weight is going to be 2 moles times 32.5 grams per mole. So that's going to give you 65 grams. Oh, we did that before in the long math way. We're just saving all of our really complicated math to the end. Ah, well, how much marshmallow are you going to need in grams? Oh, well, how much did you need initially? Well, you needed 2 moles of marshmallow. And you needed, it's got a mass of 5.5 grams. That's 11 grams. And the same thing with your chocolate. You needed 2 moles. It has a mass of 11.5 grams per mole. That's 23 grams. You guys did this the last time. So why am I showing you both ways? A couple of reasons. I learned the old school math way. There are some cases where you don't have to find everything. You need to find one thing, where you either need to find the mass of one reactant, or you just need to find your products. And it's a lot easier just to do one thing, and you don't need to do the table. It's faster. It's beneficial to use your math skills. There are cases where if you do things this way, it's showing that you understand the concept. If you can just flip things back and forth, you can manipulate numbers and not actually show that you know what's going on. If you can do this, you may not get numbers, but you can say, wait a minute, I can see what's going on in the process. I understand a chemical reaction. I can use the model. You may actually show better depth of knowledge. And if you have to find everything in the problem, all the work's done for you, and then you can just say, okay, what pieces of information do I need? You have to remember that if things are not a 1-to-1-to-1 reaction, you need to understand, wait a minute, in this case, I had more graham crackers than marshmallows in moles. I need to be able to understand and be able to show that, oh, I needed twice as much of this. I better show that I've got twice as many pieces. And when we get further along and talk about limiting reagents, that gets to be important. Both work. I learned this later in life. I like using it. You absolutely positively have to do your math at some point. I'm going to do another problem here in another video, and I'm going to show both ways, and I'm going to keep showing both ways. Pick what works best for you. If you do a higher level class, at some point, you're going to need to do the old school math method. It just works more quickly. But I think this is a really good way until you're comfortable of showing that you know what's going on. So I'm going to show another example just with marshmallows. And I'm going to have the work all done. So we'll move a little bit more quickly. But hopefully this is helping. And I'll be back in a flash.